I wanted to go over some highlights for the linear and exponential lab this week. This lab is a little bit longer than what we've done in the past, and this is just a concept that sometimes students struggle with. So let's look at the first one. I have an example here. This is just an example, a linear example already worked out. Katie's Katie inherited 150 coins from her father. Okay, you have to read. That's why, again, this class is quantitative literacy. We're reading math. Inherited is a positive number. Okay, that means somebody gave you something. So this 150 is going to be a positive 150. Her goal is to add 5 coins. Well, again, we have another word that means positive, and it means add. For linear and exponential, you're going to have addition or subtraction type words, okay? And so our starting amount is 150 coins. Notice that is positive because she inherited a positive number of coins. And her rate of change, also known as slope, is going to be plus 5. Now, that means this is an increasing function because that slope is positive, okay? And you can read for yourself these things that I've got. She's going to increase at a constant rate of 5 coins. Every single year, it's going to be 5 more coins, 5 more coins, 5 more coins. It's going to be consistent every single year. The linear equation is y equals f of x plus 150. Now, I want to stop here because on Hawks, you're going to have to write a function. A function is just another way to say y equals. So we're talking about coins. Maybe we would use an x here for y. So this function might be c of x. Again, C was chosen because we're talking about coins, and coins start with a C. And then you would have 5x plus 150. You need to know that this is function notation, where you put the C of x, okay? And you will have some of that on Hawks. You plug into the formula, and this will tell you the total number of coins. Okay, I think that's pretty self-explanatory. So let's go to the examples that you're going to have to do. I just want to highlight some things about each problem. Lisa Scrub-a-Dub-Dub maid service, Scrub-a-Dub maid service charges an initial fee of $20. Okay, so they charge you a positive $20. Plus, keyword there, that means you're adding, it means it's positive. Okay, plus means positive. $10 for every hour spent cleaning on your house. Now, this number right here, this is your constant. The initial, oh, I'm sorry, scratch that out. This is your initial fee. This is your starting fee. That's what I meant to write, excuse me. This is your starting fee. Every single person that hires out Scrub-a-Dub to clean their house is going to pay $20, okay? No matter how big or small the house is. But this number is the number that changes. This is the rate. And this number changes based on how big or small your house is. In other words, how long it takes them to clean your house. You got a really small house, so it won't take very long. You got a huge mansion, it's going to take a while. Okay, so our starting amount, and then we have our rate. Growth or decay, you can look at our previous examples. You can write an equation. Now here, you can either give it y equals, or, that's fine, you might want to write it as a function. So C seems to be pretty popular. Since this is a cleaning service, we might do C of X. Either one of these are fine. I just want you to know that a function is the same as y equals, function notation. The table, I've started it for you. You need to fill out these last 2 blocks. So I filled out the first 3, you fill out the next 2. Let's go to number 2. The water depth of a pond is initially 24 inches and decreases. Okay, key word here, decreases. This means that it goes down. This means that this rate is going to be negative, okay? Now, you started with a positive amount of water. You started initially, key word there, with 24 inches. So you started here, and evaporate means that the water is going away. So you had 24 inches, and every day it evaporates, and the amount of water goes down and down and down just a little bit per day. I think that's pretty self-explanatory. Again, for your equation, you may want to say y equals, or you may want to use function notation just to practice that. Let's see, we're talking about a pond. So maybe here I would call it P of X. and then I would set that equal to my equation. I just want you to be familiar with function notation because that will be on hogs. Okay, let's move on to exponential equations. Again, I have an example. The student population of a school with 1,200 students. Okay, this is a positive number of students. Is predicted to grow at a rate of 3%. Now, I went over this last week, so if you missed my videos last week, you need to go back and watch them. But we're going to use the formula here. If we have a percentage, it's going to be y equals a 1 plus r raised to the x power. If you ever have a percent, you're going to use this formula, and your percent is going to be converted to a rate. Now, this is going to be 0.03 as a rate. That is very, very, very important. How did I get that? Well, I just divided 3% by 100, and that gives me 0.03. So make sure that you plug in 0.03 for your rate. You can see that I did that here. We are growing. Okay, grow means positive. It means it's going to get bigger. Our answer should be larger than 1,200. And you can see we plugged it in, we get 1,613 after 10 years. A decade is 10 years. So moving on to the examples that I have for you. Derek is training for a marathon. His current running distance is 5 kilometers. For the next several weeks, he will increase, that word is really important, his distance by 10% each week. This is exactly like the example that I have on the worksheet. So you're going to go to this example. We're going to use that same formula. An equation, you could have y equals, or if you want to write it in function notation, let's see, what would be a good letter? We're talking about Derek training for a marathon. We're talking about his distance. So maybe d of x would be a good function variable to use. And right here, you have to fill in just a few spots on the table here, here, and here. Notice you do have decimals. Round to the nearest hundredth place. This is very, very important. We are still having rounding issues. That means 2 decimal places. Now, we've already done a decimal lab, but the word 100 has 2 zeros. If you look at the word 100, there would be 2 zeros. So what that tells me is the word hundredth means I need to round to 2 decimal places. So make sure you round correctly. Technically, this should have a 0 right here, and this should also be 5.00. Forgive me. Number 2, there are 20,000 owls in the wild. Okay, so there are currently existing live owls. I'm going to put a positive there. But the population is decreasing by 8%. Again, this is your rate, and that word decrease is very, very important. What does that mean in terms of the number of owls? For your equation here, you can always write y equals, but maybe if you want to use function notation, you would do maybe O of x for owls. It's pretty unusual that you would have an O for a function, but it would be fine. It fits the problem. Right here, we're going to round to the nearest whole number. Okay, that's very important. Why for this problem did I say round to the nearest whole number? The reason is you can't have half of an owl. You can either have an owl or not an owl, but you can't have a partial owl. So that's why this particular problem, you're rounding to the nearest whole number. So make sure in these spots right here that you're evaluating that you have the number of whole owls. Part 3, this is a little bit different. We're going to change it up. So you're going to determine whether or not it's linear or exponential. Determine whether it represents growth or decay, and write the equation. Let me just give you some hints here. Linear words are typically addition or subtraction. If you hear addition or subtraction, you've probably got a linear equation. Whereas exponential words are typically multiplication or some type of division. You might have a fraction, you might have a word like triple, quadruple, double, something like that. Now, all of this was in my video from last week. So again, if you haven't watched last week's video, you're probably confused on what I'm talking about. Go back and watch those videos. A library has 4,000 books. These are positive, and they are adding 500 more each year. Those would be your keywords. A bank account starts with $700. For every quarter, the amount is triple. That would be your keyword. Number 3, the population of Rhode Island is decreasing at a rate of 2%. Okay? And right now, we have 789,326 people. Number 4, the start of the county fair, you have 50 ride tickets. That means you have 50 positive little tiny strips in your pocket. I know people don't use tickets anymore. I think everything's electronic, but it used to be old school. You got a ticket. Every time you ride a roller coaster, you must pay 6 tickets. Now, here's a question for you. Does pay mean that you get 6 tickets? Or does pay mean that you give 6 tickets? That's going to determine whether that number 6 is positive or negative. If you pay someone, do you get 6 tickets or do you lose 6 tickets? So that's for you to think about. Here there are 25,000 owls. That would be positive. And every decade the number of owls is halved. Key word there. This part is, there are tables. So what you're going to do is you're going to match. This is a matching activity. And what I would do is start with 0, okay, for each of the 4 equations. And then pretty easily you can kind of see if it's 2, 5, 10, or 5. And then from there you would have to go to 1 and determine your answer. But you will not have to go past 1. So you shouldn't have to go past here to determine which equation goes with which chart. Number 10, you drink a beverage with 120 milligrams of caffeine. Each hour, the amount of caffeine in your system decreases, key word there, by about 12%. Now, notice you have a percent. This is a rate, and you need to convert that to a decimal. That is very, very, very important, okay? You can answer those questions for yourself. Make sure you round correctly. This says round to the nearest hundredth place. That is 2 decimal places. A local TV station has 60,000 viewers. That would be positive. The manager station plans to increase their viewers by 3% a month. Again, this is a rate, and a rate needs to be written as a decimal. Now, this problem says round to the nearest whole number. Why does it say a whole number for this problem when in number 10 it let me go to the nearest hundredth? Because number 11 is talking about human beings, and we can't have a decimal of a human being. So that's why you round to the nearest whole number. Make sure you're paying attention to the rounding instructions. Number 12, an assignment is worth 300 points. So you can get up to 300. That would be positive. For each day the assignment is late, the professor deducts 10 points. Now you have to decide for yourself, what does the word deduct mean? Number 13, a certain type of bacteria placed in a jar. Initially, there are 25 bacteria. The number of bacteria quadruples every hour. The key word there is quadruples. What does that mean? And the last one, number 14, cases of polio have been virtually eradicated, okay? Eradicate means to go away, okay? So that basically means, like, for example, we're trying to eradicate the COVID virus. It's not going to happen, but that's what the vaccine is sort of designed to do, even though in this fallen world that we live in, we'll never be eradicated of COVID or polio or anything else, but that would be the goal. There were 35,000 cases in the 1940s and 50s, but because of the vaccine, the number of cases have been cut in half. There's the key word right there, half. What does that mean mathematically? Since it was introduced in 1955, okay? And so here you're going to round to the nearest whole number, again, because we're talking about human beings. We are talking about people, and you cannot have a decimal of a person. So I hope that was helpful. Those are some hints for the lab this week. Take your time, go through it carefully, and we'll see you again.